Sana tak faham apa-apa ni. Dah lama ni spend time ni. Tidur sini. Aduh.
Okay, ZAIM, don't worry about your test. I will explain to you Chapter 8 about correlation and regression. First, you must know about covariance and correlation coefficient. You also must know how to interpret the relationship between two variables, and you must understand the concept of linear regression and find the equation for the linear relationship between the two variables. So first, scatter diagram. Scatter diagram is graphical technique used to show the relationship between variables. There are 4 types of scatter diagram, which are negative non-linear, positive linear, negative linear, and lastly, no relation. Next, you must know what is covariance. Covariance is a measure on how much the variables of x and y vary together. So, there is 3 types of covariance, which are large negative covariance, near zero covariance, and large positive covariance. So, the equation for the covariance is the sum of x minus of mean of x multiplied by y minus mean of y, and it is divided by n minus 1. So, let's take a look at the example. To find the covariance for this question, first of all, you must find the mean of x. So the mean of x, you must add all of the x value and divide it by 8, and you will get 10.25. Next, you must find the mean of y. You must add all the y value and divide it by 8, and you will get 20.5. For this value, you must minus the value of x with the mean, and you will get negative 2.25, and so on for this value. And also y, you will get the value for each of the data. So, to get the covariance, you must divide the value of x minus mean of x and y minus mean of y, and you will get all of this value. Next, you must add all of this value to get the sum of x minus mean of x multiplied by y minus mean of y, and you will get negative 16. Next, based on the equation just now, you see that the sum of x minus mean of x multiplied by y minus mean of y must be divided by n minus 1. So in this question, the n is 8. And to get the covariance, you must divide it, the value that we get just now, negative 16, divided by n minus 1, which is 8 minus 1 equal to 7, and you will get negative 2.2857. So it is clear that this covariance is negative covariance. Okay, next, you must know about coefficient of linear correlation. It is used to measure the strength of linear relationship between two variables, which is independent and dependent variable. It is also called Pearson's product moment, or symbol R. So for the coefficient, it will by calculate by covariance of x prime, y prime. So the equation is covariance of x, y divided by SS and SY. Or, to make you understand, R is equal to SSSY over square root of SSS multiplied by SSY. So what is SSSY? SSSY is the total of XY minus total of X multiplied total of Y divided by N. For SSS is total of X square minus square of total X divided by N. And for SSY is total of Y square minus square of total Y divided by N. So there is three types of correlation coefficient value, which is perfect positive correlation. A change in value one variable will predict change in same direction, which is the coefficient is +1. Next, perfect negative correlation, which is the coefficient is -1. And lastly, a coefficient of 0. No describable relationship between fluctuation of variables. So let's take a look at the example. In this question, it needs us to explain the result obtained for Pearson product moment correlation coefficient, which is R. So, as we know, the equation is R equal to SSSY over square root of SSX multiplied with SSY. So first, calculate the total of X, which is 108, and the total of Y is 231. Next, calculate the sum of X square, which is 1500, and total of Y square 8799. And lastly, the sum of X, Y, which is 2830. To calculate the R, we must know the value of SSXY using the real equation. So use the value that we got just now, which is 2830 minus by 108 multiply with 231 divided by 8. We got negative 288.5. And total of SSX, we use the same equation that we got just now, we will get 42. And for SSY, we will get 2128.875. As we got all the value that we needed, we can calculate the value of R. Just use the value that we got just now, and we will get the value of R is equal to negative 0.9648. And we can conclude that the R that we know just now is perfect negative correlation. So next is regression. Simple linear regression. So you must know the equation of the regression model, which is y is equal to b0 plus b1x plus e, and b0 is referred to y-intercept, b1 is referred to the slope, and e is referred to the experimental error. E is the residual, or it is the difference between observed value of y and predicted value of y at a given x. The sum of residual is exactly 0, and the mean value of the experimental error is 0, and the variance of experimental error is denoted by this. And the regression model is estimated by using sample data, or it is also known by the method of least square. So B1 we got from the divided of SSXY and SSX, and B0 by mean of y minus B1 multiplied with mean of x. Or to make you understand, delta total sum of y minus B1 total sum of x divided by n. And the equation of line of best fit, or to the estimated regression, is known as line of best fit is equal to B0 plus B1x, or observed value y is equal to B0 plus B1x plus E. You must know, ZAIM, a scatter diagram may suggest curvilinear regression. If two or more input variables are used, it is called multiple regression. So ZAIM, next, you must know about experimental error. So what is experimental error? Experimental error is errors that may occur in the execution of a statistical experimental design. Types of experimental error include human error or mistakes in data entry, systematic error or mistakes in the design of experiment itself, or random error caused by environmental conditions or other unpredictable factors. Experiment design seeks to minimize experimental error in order to produce the most accurate data possible. So, formula for variance of experimental error, or it is rewriting as S is squared. For the formula for the variance of experimental error is the sum of square of y minus y hat divided by n minus 2. So, as we know, y hat is equal to B0 minus B1x. As we substitute, we can get the equation the total of y squared minus B0 times by total of y minus B1 times total of x, y, and divided by 2. And we can conclude that SSE over n minus 2, which is SSE is sum of square for errors, which is referred back to total of square of y minus y hat. So let's take a look at the example. A recent study was conducted to determine the relation between advertising expenditures and sales of statistic texts. The data is given below. Find the line of the best fit and variance of y about the line best fit. So this is the data given. First of all, we must calculate the total of x, which is we get 459. Next, we must calculate the total of x squared, which is 21,677, and the total of y is equal to 3,699, and the total of xy is equal to 174,163. So, to calculate the line of the best fit and the variance, we must find the S as x. Using the earlier equation, we get 608.9, and next we must calculate S as xy. Using also earlier equation, we get 4,378.9. So, to calculate B1, we use equation S as xy over S as x. So, we will get 7.1915. To calculate B0, we use equation total of y minus B1 times by total of x over n. So, we will get 39.8105. As we know, the equation for the line of best fit is y hat equal to B0 plus B1x. So, we will get y hat equal to 39.8105 plus 7.151915. So, for the observed value, we will get 39.8105 plus 7.1915x plus e. So, we got the first question that they asked, which is the equation for the line of best fit. And next, we must find the variance. So, as we all know, the equation for the variance is total of y squared minus B0 multiplied with total of y minus B1 multiplied with total of xy, and they will be divided with n minus 2. So, as we got the value for each of the data needed, we just use the value and we will get the final answer, which is 1,341.8244.